Hello students. Now we will be starting our next topic, vector atom model. This is the first topic in your syllabus. By the introduction of quantum mechanics, the theory of hydrogen atom became more clear. Right? The Schrodinger's equation solution yielded the quantum numbers n, l, ml, etc., which you have studied in your degree classes, where n is the principal quantum number, l orbital quantum number, quantum numbers 0 to n minus 1. The orbital angular momentum L, capital L, it is the magnitude is equal to root of L into L plus 1 h cross, and ml is equal to magnetic quantum number space quantization. ml is equal to minus L to plus L with 2L plus 1 orange. To explain the fine structure of atomic spectra, spin of electron is introduced. This is the important thing in vector atom model. The spin of the electron is introduced in order to explain the fine structure. Okay, the spin was a quantity which is inherent and a fixed property of an electron. So spin of an electron is not a changing parameter, it is an inherent and fixed property of electron. Such a new physical quantity has incorporated in vector atom model. Okay. Thus, the total angular momentum contribution to any atom by a single valence electron is made up of two parts. Right? First one is the motion of electron around the nucleus in an orbit, and the second is the spin motion of electron about its own axis. So these two contribute to the total angular momentum. Now the other quantum numbers are, when we introduce spin, it is a spin angular momentum and its magnitude is given by root of s into s plus 1 h cross with the magnetic spin quantum number ms. By space quantization, ms has a values minus s to plus s. If s is equal to half, ms can have values plus or minus half. Okay. Since electrons in an atom has both L and S, these two angular momentum combine to get the total angular momentum J for the electron. So J is equal to L plus S. So there is one more quantum number, the total angular quantum number, and the total angular momentum capital J. Its magnitude is given by root of J into J plus 1 h cross. And the magnetic total angular momentum quantum number Mj varies from minus J to plus J. So there is a spin-orbit interaction between the spin quantum number S and the orbital angular momentum L. So there are of two types of interaction between spin and orbital angular momentum interaction. The first one is LS coupling. It is also called Russell-Saunders coupling. The second one is JJ coupling. These are the two incorporated in our system. The first one is LS coupling. This occurs in lighter elements and strong magnetic field B is applied. So when coupling between individual Li and Si are weak. So in such a case, the individual L and S will not combine each other. The L of each electron, L1, L2, etc., L1 plus X, they combine to form the total orbital angular momentum L, where I is the number of valence electron, right? We only include the valence electron quantum numbers. Okay, so L is the total orbital angular momentum, and similarly we get the spin angular momentum S1, S2, S1 plus S2 plus etc. to Si, which is given by the total S, total spin angular momentum, and the total angular momentum J is the total of L, this total L and total S. So the individual L1 and S1 are not combining here. This occurs in the case of lighter elements and strong magnetic field B. Okay. Now, if L is less than S, J has 2L plus 1 values, and if L is greater than or equal to S, J has 2S plus 1 values in LS coupling. So this term 2S plus 1 or 2L plus 1, this is called the multiplicity. That is, when S is equal to 0, J is equal to L. Such a case is called the singlet state. That is 2s plus 1 is equal to 1. We get it as 1, right? So it is called the multiplicity is 1. So it is called the singlet state. When s is equal to half, you get 2s plus 1 is equal to 2. That is called a doublet state. When s is equal to 1, you get 2s plus 1 equal to 3. That is a triplet state. Okay, so this is how we can divide or clarify the multiplicity. So it can have singlet state, doublet state or triplet. Now the second is JJ coupling. This occurs in heavy elements where coupling between individual Li and Si is considerable to form Ji. So individual electrons L and S combine to form the individual Ji. So Ji is equal to Li plus Si, or J1 equal to L1 plus S1, J2 equal to L2 plus S2, etc. And finally the total J is summed as the individual Ji's, J1 plus J2 plus etc. So in such a way you get the total angular momentum J vector. Now next is the term symbol. The entire spectroscopic notation of the electronic state of an atom according to its total orbital angular momentum quantum number L is given by a term symbol which is represented like this: L 2s plus 1 J with N in the front, N 2s plus 1 L J, where we have capital L is equal to 0, 1, 2, 3, etc. for S, P, D, F, etc. These letters are capital letters which symbolizes the entire spectroscopic notation of the electronic state of an atom. So here we choose it as capital letters of S, P, D, etc. So this is the entire notation of entire spectroscopic notation of an atom, right? This 2s plus 1 or 2l plus 1, according to this variation you get it as 2s plus 1 or 2l plus 1, which is called the multiplicity, and n is the principal quantum number. So we can take one example to find the term symbol. So 1 is half. This is read as singlet S half. 1 singlet S half. This is read as 1 singlet S half. That means the principal quantum number n is 1. This represents the value of L. That is, L is 0. Now S is equal to half. S is equal to half. Since L is less than S, there will be 2L plus 1 values. Okay. So S is equal to half. J is equal to 1 by 2. According to this term, you can deduce all the quantum numbers of that electronic state: N, L, S, and J. This is read as 1 singlet S half. One more example. This is 1 doublet P 3 halves. 1 doublet P 3 half state. So here L is equal to 1. Since it is P here, L is equal to 1, S is equal to half, N is equal to 1, and J equal to 3 by 2. Since J is equal to 1 plus or minus half, it can have two states. That is 1 plus half 3 by 2 or 1 minus half 1 by 2. So it is a doublet state. So this 2 here, it is read as doublet P 3 half. Okay.